Right, now let's talk about the last part of this topic, which is the solubility of sulfates and carbonates of group 2. Now, first thing that you have to know is the general trend, is that as you go down the group, they become less soluble as you go down the group. Now, why is that? So, we know that, for example, in group 2, magnesium, calcium, barium, blah blah blah. As you go down the group, what happens is that the solubility of uh, of sulfates and carbonates decreases. So of sulfates and carbonates decreases. Now, why is that? The first trend that you see is that the radius of the cation is increasing, right? So we have magnesium here, we have calcium, and then barium will be bigger than this. So the radius is increasing. Remember what we said about when the size increases but the charge remains the same, because both of these are plus 2, right? So this one, the charge of plus 2 is spread around more area than this one. That means that this one has a lower charge density, and this one has a higher charge density, right? So that's the first point. Now, something which is a higher charge density will have a higher lattice energy than something which is a lower charge density. So as you go down the group, because the charge density is getting lower, the lattice energy is also getting lower. So the enthalpy change of lattice also decreases as you go down the group. And also, the enthalpy change of hydration also decreases as you go down the group. And this is a similar concept to why hydration also decreases. Remember earlier we said that hydration is more about forming bonds with the water molecules. So if the charge density is more, then there's more attraction with the water molecules. So the bonds are uh, there's more energy released. But if the charge density is lower, then also the attraction is not that much, and thus the energy is lower as well. So as you go down the group, both lattice and hydration decrease. Right, now before we continue, I just want to show you one thing, which is the equation for how this works. So basically, now you're talking about solubility of something. You're talking about solubility. This is the enthalpy change of solution, right? We are dissolving a solid in water. So for example, let's take MgCl2 as a solid. When it dissolves in water to form MgCl2 aqueous, right? I can represent this like this: Mg2 plus plus 2Cl minus aqueous, because it's MgCl2. And this part over here on top is the enthalpy change of solution. But we can draw a Hess cycle for it. So in the bottom here, you can keep Mg2 plus gas plus 2Cl minus gas. Remember how we used to do the Born-Haber cycle stuff? And then you can form an arrow here, and you can form an arrow here. This is enthalpy change of, this is gas forming a solid, so this will be lattice. And this is gas forming an aqueous. This is hydration, right? Because we see hydration is when 1 mole of gaseous ions dissolves in excess water to form 1 mole of aqueous ions in an infinitely dilute solution. So we can see that this will be the vector direction. So this plus this will give you this. So you have enthalpy change of solution plus enthalpy change of lattice equals to enthalpy change of hydration. If you bring this here, it becomes solution will be equal to hydration minus lattice. Now we say that as you go down the group, the enthalpy change of lattice and hydration both become less exothermic. They become less exothermic. So both of them become less exothermic. Less exothermic. Now, if something becomes less exothermic, let's say it's negative 50, now it's negative 30. This means that its value is increasing, right? Because you have added 20 to this. Okay. Now, the change in the hydration is much greater than the change in the lattice enthalpy. So, it's that both of them are becoming less exothermic. This one is becoming less exo, and this one is becoming less exo. but the change in this one is more than the change in this one. So for example, the change in this one is 20 and the change in this one is 10. So when you subtract this, you will get enthalpy change of solution to be positive 10. So the change in solution is positive 10. So that means that the change of enthalpy change of solution is increasing by 10, which means that it's becoming more endothermic. So enthalpy change of solution is becoming more endothermic as you go down the graph. Let me repeat that if it was confusing. So we say that as you go down the graph, right, when you go from magnesium to calcium to barium, both enthalpy change of lattice and enthalpy change of hydration become less exothermic. When they say less exothermic, it means that it's it's becoming more positive, right? Because you can go from negative 50, which is more exothermic, to negative 30. Now, the change which happens in this hydration, so hydration, the change will be more than for the lattice. So let's say the hydration, the change is positive 20, and the lattice, the change is positive 10. So when you want to find the change in the solution, you do positive 20 minus positive 10, which is positive 10, which means that the enthalpy change of solution is increasing by 10, right? So it's becoming more endothermic. It's increasing. It's becoming more endothermic. So the solubility will decrease. Now, this is something that you have to know, that the more endothermic it is, the less soluble it is, right? So they go opposite. If something is more exothermic, then it's more soluble. So this is how we get our trend that therefore the enthalpy change of solution becomes more endothermic, which indicates a decrease in solubility. Now, this is something that is very important to understand, and I'll emphasize that you watch the video again if you didn't understand, because in CIEs they ask this question and it's usually 4 marks. And to be honest, if you didn't understand the explanations, just cram this, like literally cram this, because this is very important. And yeah, don't go in your exam without understanding what these things mean. And usually it will be 4 marks, and you will have to write down exactly as how I have kept for you over here. Now we also have another trend which you have to be aware of, and this is of group 2 hydroxides. Right? Now, as you go down group 2, the hydroxides become more soluble. So this time, you are going down, as you're going down group 2, they are becoming more soluble. Now, you remember we say that solubility is, for example, something which is more exothermic is more soluble, right? So you will get the idea that as you're going down, these things are becoming more exothermic. So the enthalpy change of solution is becoming more exothermic as you go down the. Now you remember how we made the equation for enthalpy change of solution? We say that enthalpy change of solution is equal to enthalpy change of hydration minus enthalpy change of lattice. And as you go down the group, both of them become less exothermic. And this is always the case, that both of them become less exothermic. But for the sulfates and carbonates, we say that the change in this one, the change is more than the change in this one. And we give an example of positive 20 and 10 as an example. Like the change in this one will be positive 20 and the change in this one will be positive 10. So this one will be positive 10. But this time, it's not this way. It's the other way around, which is the change in lattice is more than the change in hydration. So this time, the positive 10 is over here, positive 20 is over here. So now, when you minus it this time, here you don't get positive, you get negative 10, which means that the enthalpy change of solution is becoming more exothermic. The change is exothermic. So that's why the solubility increases as you go down the graph. Right, that's it for this topic of lattice energy. I hope these concepts are clear. There's a couple of very important concepts that I hope you understood, especially regarding solubility, regarding how to draw the Born-Haber cycle, and regarding how to form those equations regarding S law, and how do you connect those equations and how do you form them. Right, thank you for watching. We'll continue with solved past papers, and at the end I'll leave for you a worksheet so that you can try it out yourself as well.